In this chapter, we'll learn about a new mathematical quantity called vectors. It turns out that in physics, quantities like force, momentum, uh, acceleration are all represented by vectors. Uh, Vectors are quantities that have both magnitude and direction. So here's how you represent a vector by a directed arrow segment. So this could represent a force, velocity, whatnot. But anyway, this is a general vector. All right. So scalars are quantities that have magnitudes and no direction. So to specify a scalar, all you need is one number. To specify a vector, you need more than one number. It will depend the numbers the number of numbers you'll need will depend on the dimensions you are in. In 3 dimensions, you need 3 numbers to specify vector quantities. Okay, so if you're in 3 dimensions, you need 1 number to specify the length of the vector and 2 numbers to specify its directions. In 2 dimensions, in this diagram in 2 dimensions, you need 1 number to specify its magnitude and 1 number for its direction. Okay. Here's the notation. Vectors are represented by bold letters with an arrow on top. The absolute value signs are on the vector tells this is how you write the magnitude, or you can write the magnitude like so as well. So there are quantities in physics that have to be represented using vectors, such as force, acceleration, momentum, displacement, and so on. And there are quantities in physics that are represented using, all you need is one number to specify them, such as pressure, temperature, and so on. Okay. So this entire chapter is about vectors, and essentially what we are going to learn is how to add vectors and how to multiply vectors. Add, subtract vectors, and multiply vectors. So essentially we're learning the algebra of vectors, how to add and subtract them. Okay. So let's define our first vector. We'll define the displacement vector. Let's say you start at point A and you go to point B. Now you can go to point B any way you like. For all these different paths, well, your displacement vector is a vector drawn from A to B. That straight line vector drawn from A to B. That's your displacement vector. Okay. So your displacement vector is the same for all these different paths. And it's a vector because this quantity has a magnitude, the distance you travel, well, the magnitude, which is the distance between point A and B, and the direction. All right, so now let's start with, let's see how let's work our way towards adding and subtracting vectors. So here's a vector A, and what this diagram is showing is vector B, which is twice A, and that's intuitively clear. B should be twice the length of A and in the same direction as A. C is a vector minus 2 times A, which means it's twice the length of A, and the minus sign tells you it's in the opposite direction. So now we've introduced to you what we call a scalar multiplication. You're multiplying a scalar to a vector, and we've introduced the negative of a vector, what a negative of a vector means. Okay, so if you have 2 vectors like this and you want to add the 2 vectors, here's the graphical method of adding the 2 vectors. You draw the first vector, and it doesn't matter which you draw first, and then you draw the tail of the second vector on the head of the first vector. So that's how you add vectors. And the resultant vector is from this tail of the first vector to the head of the second one. Now these are collinear vectors, and that's easy, so let me show you an example of, so let's say here's a vector A, and this is a vector B. This would be the sum or equal to A plus B. Okay. Of course, these A and B are different from these A and B's. Okay. So that's how you add vectors. And this can be generalized to as many vectors as you want. A, B, C, D. You can keep doing that. And there is the resultant. Resultant equal to A plus B plus C plus D. Okay. So now you learned how to add vectors. Now here's another property of vectors. A vector has magnitude and direction, but you can draw it anywhere you want. You can parallel transport it. So this vector is equal to that vector. These both these vectors have the same magnitude and the same direction, and so they are equal to each other. So what this physically means is, so for instance, if you drive for people from this area, if you drive north on 95 at 75 miles an hour, your speed is the same as if you drive north on some other highway at 75 miles an hour. Okay. Your velocities would be the same if the magnitude and direction are the same. Okay, so that's what that means. All right, so we learned how to add vectors. Now, you want to add two vectors, and I showed you how to add vectors graphically. Here's the first vector, here's the second vector. A plus B is equal to C. Okay. So these were the two vectors given, and if you wanted to add them, all you did was bring one vector to the tail of one vector to the head of the second vector. Okay. And it wouldn't matter whether you did A, you added the tail of B to A or the tail of A to B, and you would get the same result. Okay, so what I'm saying here is A plus B would give you the same result as B plus A. The result would be the same. R would be the same. Okay. So now this way of adding vectors, you can add as many vectors as you want. Um, this shows you how you've added A, B, C, D, E. So the resultant vector is this vector. It's the vector from the first tail of the first vector to the head of the last vector. Okay, so this slide shows you that A plus B is the same as B plus A, the same as B plus A. And this law is known as the commutative law. So vectors obey the commutative law with respect to addition just like numbers. See, numbers obeyed that. This was equal to 9 no matter which way you added them, and we were just checking to see if vectors also obeyed this law, and they do. So this is the commutative law of addition. The associative law of addition says, okay, so with numbers, it didn't matter what, if you were adding multiple numbers, it didn't matter what order you added them in, and you always get the same answer. So, okay, and it turns out that vectors also obey that associative law of addition. And this graph shows you that equation. So this is adding B plus C first, adding A to B plus C, and there's adding A to B plus C. There's B and there's C. This is B plus C. A plus B plus C is the left-hand side, which is equal to that. And A plus B is that. And you add C to that, you get the same answer. Now let's define the negative of a vector. The negative, if a vector B is like that, minus B is defined in this way. So minus B has the same magnitude as B, except it's pointing in the opposite direction. And that's the intuitive definition of it, and that's what we're going to take as the definition of negative of B. Alright, so A minus B just means A plus of minus B. Now you already know how to add vectors, and now that you've learned the definition of minus B, now it's just A minus B just means adding A and minus B. So there is A parallel to itself, and there's minus B. So there is A minus B. So now you have learned addition and subtraction of vectors. Yeah? And we will we'll learn how to multiply vectors. It turns out, well, we'll get to that in a second. Okay, so one more thing, we've already introduced this, but here's a scalar multiplication of a vector. You're multiplying a scalar to a vector, and you already saw what this means. So if this was 3a, 3a just means a vector 3 times a and in the same direction. So you know what 3a means, you know minus 5a, etc. Okay. All right, we'll pause the video now.